All right, next example, 6x squared plus 19x minus 7. We have a trinomial. A is not equal to 1. So we're going to use the grouping method for doing this. So we multiply A times C. In this case, I might just write over here, A times C. 6 times negative 7, which is negative 42. Okay? I can make my chart factors of negative 42, things to multiply to be negative 42. They add to be B, or this middle term, which is 19. Whoops. So, again, now I'm thinking about multiplying to get a negative number. Okay, if we multiply to get a negative, we have a positive times a negative. If we add those same two numbers and get a positive, the larger number is now positive. So maybe, now, if we're just kind of willy-nilly about this and we just go, oh, 6 and 7, it's 6 and 7. Be careful, right? Because that's one of the main ones we can think about. That's why I like to be a little bit more careful. Negative 1 and 42. Negative 2 and 21. Will 3 go into 14? No. Yes. Negative 3 and 14. 4 doesn't go into 42. 5 doesn't go into 42. Negative 6 and positive 7. That's going to be it. Hopefully you can see, and you could have stopped before now, that negative 2 times 21 is negative 42. Negative 2 plus 21 is 19. So we're going to rewrite this problem, 6x squared. It doesn't really matter which one you do. So I'm just going to go with negative 2x plus 21x minus 7. And again, you can see we've strategically taken 19x and split it into two different terms that still equal 19x. So now we'll do some grouping here and here. So 6x squared and 2x have a 2x in common. Again, be careful. This will have 3x minus 1. Right, 2x divided by 2x is 1. 21x and 7 have a 7 in common, and leaves me with 3x, and then negative 7 divided by 7 is negative 1. Now we're looking at these two terms. Okay, what do they have in common is a 3x minus 1. What's left over is 2x plus 7. Now, this method generally takes a little bit of practice to kind of get into the routine of doing, but yeah, I think it's pretty good, and it's my favorite. So when I show anytime we have to factor something like this on the board, this is the method I'll use. Again, if you like something else and you're good at it and you know it, go for it. Otherwise, if you ask me how to do something, this is probably what I'm going to show you how to do. Okay? All right, question. Oh, I can't take questions. Darn. I'm so used to saying, can I take some questions? But I can't. So, good luck. All right, next. Number 5, difference of two squares. We talked about this a little when we were talking about multiplying conjugates the other day. The difference of two squares. You will know that you're dealing with the difference of two squares. In fact, all of these words help us out. We'll have two terms, right? We'll be dealing with a difference, so that's subtraction. And I'm going to actually put in parentheses only, because that's going to be interesting later. And then squares. Terms that are perfect squares. Okay, and this would mean the coefficients are perfect squares. So again, that list of perfect squares you might have in your notes, 1, 4, 9, 16, 25, 36, 49, so forth. Coefficients and variables to even powers are also perfect squares. Okay? X squared, right? X to the fourth is also a perfect square because we can rewrite it as x squared squared. Okay. X to the sixth is a perfect square because we can rewrite it as x cubed squared. And we'll just say etc. Okay. Here's what it looks like. A squared minus b squared. It's the opposite of when we multiplied conjugates. We get a plus b, a minus b. Okay. So let's look at a couple of examples here, maybe several. Factor. 1. X squared minus 81. Sometimes what you might want to do, and again, this one isn't so bad, but in some of the problems, it might be nice if we write underneath what was squared, right? X was squared. What was squared to make 81 is 9. So that I know when I fill in to this pattern, instead of A and B, I'll be using X and 9. So this one is X plus 9 and X minus 9. Okay. Number 2, 36x squared minus 25. So we might have to think about what is squared to make 36x squared. Well, we squared 6x to make 36x squared. Remember, using the power of a product. And what was squared to make 25 was 5. So that, again, when we fill this in place of A and B, I'll be using 6x and 5. So we'll have 6x plus 5 and 6x minus 5. Next, one more, x to the fourth minus 81, okay? So again, we have to be able to recognize that this is the difference of two squares. In that any numbers we have are perfect squares, which 81 is, and also variables to even powers. X to the fourth is a perfect square. In fact, it is x squared squared, as we mentioned earlier. And this is 9 squared. So that when we, again, follow our pattern, instead of A and B, I'll have x squared and 9. So I'll have x squared plus 9 and x squared minus 9. Okay. Now, interesting, we need to continue to look for opportunities to factor. And I might notice again that I have another difference of two squares. X squared minus 9 is a difference of two squares. In fact, it is x squared and 3 squared. So now our final answer, we'll have x squared plus 9. That doesn't go away. And we cannot factor it because it's the sum of two squares. We don't have anything about the sum. We only have the difference. And then we'll factor this with the difference of squares. But again, instead of A and B, now we'll have x and 3. So this will be x plus 3 and x minus 3. And that will be our final answer on factoring x to the fourth minus 81. Okay. So take some time to think about these problems. And I'm going to write another one up here. Okay. Then I'm going to stop this video so I can start another video. But I'm going to write another problem, and when you start the next video, the correct answer will be up here so you can check that out and see if you did it correctly. 81x to the fourth minus 16. So I'm going to stop this one again because I'm getting kind of close on time. And you try that problem, and when I come back on the next video, I'll have the answer for you.